Okay, welcome to the demonstration portion of the video. This is the prototype I made for my modular parking sensor slash blind spot monitor that you can use with an older vehicle. So the first thing, this is just a run through of how to use the prototype. First thing you want to do is check to make sure that your battery pack is turned on and connected, both of them, to the ESP32 and other sensors. And then you want to turn on your mobile hotspot on your phone. So here we go, it might take a few seconds. Tap to set up, and in order to connect, let's just press the reset button on the ESP32. Wait for a few seconds. There we go. Yep, it's connected. And then you want to open up the Blink app. Let me show this to you. And press play. So here we have an image on the bottom that shows whether if you can go forward, you can change lanes, or you need to stop. Show different images based off the mode it's in. You have the numerical display, which shows the output of the ultrasonic proximity sensor for both functionalities, as well as some switches for whatever mode you want to be in. So let's test the blind spot monitor first. There we go. So it's started. It will show an image of the no right turn if you are within 100 centimeters of an object to your ultrasonic proximity sensor, meaning a car is in your blind spot. And if you were to want to turn or change lanes when that car is in your blind spot, you'll hear a beep. So let me demonstrate that for you. Let's turn this towards this wall. Let's pretend that's another car, and you want to change lanes. You'll hear a beep. And so the IMU, the inertial measurement unit, senses when you want to change lanes and will output a beep if there's an object in the way so that the driver knows not to turn. As well as you can see there's an image saying not to turn on the display as well. So let me just try that again. Yep. Yep. Seems to work perfectly fine. Alright, so let's next test the parking sensor functionality. So here you'll hear beeps with different frequencies depending on how close the proximity sensor is to another object. And you'll see the image change to a stop sign once you are too close to another object. And so right now it's beeping rather slowly because we're pointing at a roof. But let's change to this wall again. You can hear it beeping faster. And then if we get closer, it'll get even faster until it's a solid note. And that means you should stop. You should see a red stop sign on the screen as well. And once you don't want to use either functionality, you can turn the thing off. And that's all the functions of this prototype. Thank you very much. So now that you've seen a demonstration of the prototype in action, I just wanted to go over the code and give a quick explanation how everything works, as well as show you the GUI of the app in the phone. So here in script.py is really where all the magic happens. So after importing your modules and drivers, we first start off by initializing our sensors and some variables. L1 here is the pulse width modulation that is actuating the speaker. The IMU is using I2C communication protocol, and this ultrasonic proximity sensor is just using regular GPIO pins. Next, we initialize the rest of our 4 timers. The first timer, TA, is associated with the beep callback function, which initializes when the device is in the parking sensor mode, as you can see on the GUI. And pretty much it will allow the speaker to beep at certain frequencies depending on how close you are to the object. The next timer is ultrasonic proximity sensor callback function, which samples the proximity sensor's measurement and also initializes the next timer depending on if you select the blind spot monitor mode and your distance is less than 100. So TM here is associated with the IMU, and it will sample the acceleration in the x-axis, and if this acceleration is greater than 0.15 Gs, it will initiate the pulse width modulation of the speaker to output a warning sound to the driver. But if your distance is greater than 100, it will deinitialize itself. So next here we initialize our blink communication protocol with our phone. It has two main events, the read and also the write. In the read, it's kind of counterintuitive, but here we will output the distance from our ultrasonic proximity sensor to whatever object it's pointed at, and it will also change the image. So these two widgets right here, you can see 164.21 centimeters away, as well as the blue circle with an arrow. These will change based off of this handler event. So the second handler event is in charge of changing the mode of the ESP32 and deinitializing and initializing timers based off of the user input using these three buttons here on top. So if you hit the first button, parking sensor, it'll initialize TA and TW, those two timers, and deinitialize the IMU. And blind spot monitor, it'll initialize TW, TM. And finally, if you hit off, it'll deinitialize all three timers. And these two events will constantly run in the background. So yeah, that is the entirety of the main script.